Hello everyone, my name is Akshay and today I'm sharing my presentation about day 16th challenge from IDC, and today's topics are about generators and iterators, and the challenge is to generate the first n Fibonacci numbers with a generator. Okay, so you can look at this picture that shows how the functionality of an iterator works. Okay, suppose I have a sequence of items in my list. Let's say it's 1 2 3. Okay, and I'll be calling each and every item with the iter function. Okay, so every time I call with iter and then I say next, it will call, the output will be one thing at a time, one item at a time. At the first I'll get 1, and then I will get 2, and then I will get 3, and if I call the next time again, it will say that the iteration process will not happen because the sequence, all the items are iterated. I mean all the items in the list are already displayed, and the uh, list is empty. Like that it will show. So let's look at some differences between an iterator and a generator. Okay, so iterators are the objects that use the next method to get the next value of the sequence. A generator is a function that produces or yields a sequence of values using a yield statement. Okay, classes are used to implement the iterators, and here functions are used to implement the generator. Every iterator is not a generator. Every generator is an iterator. Complex implementation of iterator protocols, that is iter and next. So we have to use it on every iteration. Okay, and in generators in Python are simpler to code than the custom iterator using the yield statement. Iterators in Python are less memory efficient. Generators in Python are more memory efficient. No local variables are used in iterators. All the local variables are stored before the yield statement. Okay, and when we look at the used cases, so iterators are used when full control over iteration is needed. Working with small or fixed data sets, repeated iterations or custom logics are required. At that time we use iterators, and we use generators when handling large data sets or infinite sequences, prioritizing memory efficiency and preferring simpler code in generators. Now let's look at some real world examples. So here the an iterator is an object that allows you to loop over, iterate through a sequence of data one element at a time. So now you can see that I have 5 items in my list called nums 1 2 3 4 5, and here I'm using iter in bracket nums. Okay, I'm trying to print the first element using next. So here I get it as 1. I'll do that again. Yeah, here it is 2. 3 4 5. Okay, so I have 5 elements in my list, 1 2 3 4 5. So every time I print next and then I call the iteration, it will print each and every element. Okay, if I do it again, just a moment, it's loading. So here, this, if this kernel status is in black, then it means that the behind the scenes some work is happening. Okay, so here it has stopped the iteration because there is no element left in my list, all are already displayed. Okay, so now let's look at a generator, how it works. A generator is a special type of iterator that's defined when a function and the yield keyword. It generates value one by one as needed. So here I don't have to use the stop iteration process. So here you can see that after the fifth iteration I was not able to execute. So in order to make sure that the execution stops, uh, I was required to execute this and show that the iteration process will not continue after this because all the elements are already displayed, right? So here in this case you can look at this short program. Here, count up to the max number, means I want to count the numbers here. So number is equal to 1, while num is less than or equal to max, this number, yield num, this number will be added to the 1 and the next number. Okay, so here what happens is all the all the numbers are printed 1 2 3. Here count up to 3. 3 is my maximum number. All the numbers are printed, but I don't have to use the stop iteration function anywhere in this program. Okay, so that is the beauty of generator. I don't need to stop the process. Once the program is met certain conditions, the iteration process will stop automatically. So that is the beauty of generators. Okay, here if I do 5, the only thing is I am calling this one 3 times. Okay, yeah, you can see that it is printed 5 times. So here the challenge is to generate the first n Fibonacci number with a generator. Okay, so I am defining the function fib a and b is equal to 0 and 1. I am assigning this value at the beginning, while true yield a comma b is equal to b comma a plus b. For f in fib, if f is greater than 100, break or else print. So this is the statement that will stop the iteration process. Okay, so once f reaches 100 value, the process will stop. Okay, by the way, yeah, yeah, so here you can see I have my Fibonacci series until it reaches 89, because after 89 the value that we get here will be greater than 100. So if I do it like 150, then I'll be getting it till 144. okay, because that is the next number. Yeah, so this is my presentation about generators and iterators, and if you really like my presentation, and if you have any kind of questions or feedback, kindly share it with me. So do comments and share your honest feedback with me. Thank you so much for your time and have a good day ahead.